Hi, this is Mr. Max here. I am doing a second part video on possibility diagrams. Okay, so we're going to look at independence events, but what I want to do is I want to do questions where you make use of a possibility space diagram. I have done a similar like video, and you can have a look on my videos there and my playlist under probabilities and statistics. You'll find that part there. Right, so let us look at an example. Say, for example, when you are rolling two ordinary dice, what is the probability that the sum of the two numbers is 7? Now, when you look at this question just like this from the onset, you realize that it is not as straightforward, really, for you to find a particular answer to this question. Right, so I suggest that you come up then with a table where you have a space here, all right, and then you have what, because the question is asking you to find the sum of two numbers. So the ones in blue here, that would be the first die, and the other one here would be the second one. And what I have done here is I've added, all right, so the one in grid is the sum. For example, 1 plus 1 is 2, and 2 plus 1 is 3, and so on. All right, so now you can actually see from this space diagram here that the possibility then would be all the sevens that are lined up here. Okay, and you realize that it is very straightforward. Out of these possible 36 is a 6 by 6 grid, right? 6 of them will add up to 7, which then simplifies to 1 over 36. To continue the B part, suppose the question asks you what is the probability that at least one prime number appears on both dies. So I am going to do this question again in this video where I'm going to use a different approach. So what I have done here is I have worked with color codings, right? So the one here, where you see it's when you have exactly have two prime numbers, and the one that is yellowish here or orangey, if you want to say that, this is when you have a combination of, let's say, a 1 and a 2, where the 2 is a prime number. All right, and when you count all these color codings that I have here, all right, you will realize you get to 3/4. But again, I will do it on a different way later on. Or even if you still work with these colors, you can just look at the ones that are in white. Obviously, those ones are indicating to me that they are not going to have one prime number in there. So if we look at the C part also, this one says the sum of the two numbers is 7 or more, and their difference is 3 or less. So again, it's kind of tricky a little bit. So you have to think of when you are adding the two numbers. So when you look at the ones that I have 3 plus 4, for example, the 7 that I have here down, all right, and if you take the difference also between the numbers here, you realize that the difference between 5 minus 3 is 1, 5 minus 2 is 3, all right, and 6 minus 3 is 3. So these ones make sense, and also the other ones on here. So those colors are indicating to me where I have the condition where the two numbers is 7 or more if you add them up, and the difference between them is 3. All right, so you can't use let's say this white one here, the 8, because 6 plus 2, yes, is 8, all right, but if you subtract 6 minus 2, you are getting 4, and our condition is that the difference should be 3 or less. Right, so let me just go directly into some questions. The one here is bringing up a diagram 1 where you have a wheel that is numbered from 0 to 4 identical sectors. So when the wheel is spun and when it stops, the arrow point to a number, and the key thing is all numbers are equally likely. All right, the second diagram shows a possible outcome. So there's a sort of a diagram, is possibility space diagram that we can use. So when there is a question, for example, what is the probability that both numbers are 4, All right, so that is going to be 4 and 4. Well, it's just going to be 1 out of all these possible 25, because this is a 25 grid here. Okay, that both numbers are going to be 4 when you spun this wheel. Okay, so when you spun it once and you spun it again, possibility of getting 4 is 1 out of 25. So let me bring that back here. So the question is asking, find the probability that both numbers are the same. So this one here is where you have like a 1 and a 1, a 0 and a 0, a 2 and a 2. So remember, our space is out of our 20, our grid is out of 25. And if you count, you'll see that you have 5 out of 25, which simplifies to 1 over 5. Then find the probability that the sum of two numbers is 6. Well, that should be very easy. If you look at 4 plus 2, that gives you 6, that's one condition. And obviously 3 plus 3 gives you 6, that's another condition. And the last one here is 2 plus 4. So 3 out of the 25. And that is the probability for that particular question. Right, then the C part is asking you to find the probability that the product of the numbers is less than the sum. Now what I have done here is I've taken the product of the numbers, so obviously I've multiplied, like 1 times 0 gives you 0, and 4 times 1, for example, is 4, or 3 times 3 is 9. Alright, so I'm going to bring in another table where I took the sum. So we're going to look for where the sum is bigger than the product, and I have indicated them here with these colors here. All right, so all of these indicate where the sum is bigger than the product. So you can count them. You get 15 if you count the blocks out of 25. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 25. So you have to make sure that you have some sort of diagram, right? And this one I didn't want to bring in triangles and squares because it becomes a little bit more problematic for you to see. Okay, let's look at a second question here. They are saying an unbiased coin is tossed and a letter selected at random from the word sure. Find the probability of getting a hat on the coin and the letter R. So a hat and the letter R. Well, out of the 8 combination, it's just going to be 1. Okay, so 1 over 8, that is the probability that you get a hat and an R. Okay, so 1 over 8. Very straightforward once you can come up with a sort of a diagram. Question 3, two dice are rolled using a possibility diagram. Calculate the probability of rolling a double. So when you have a double, it's like when you have like here, like a 3 and a 3, and so on. So I'm going to write all those possibilities. Well, it's a 1 and a 1, a 2 and a 2, 3 and a 3, and so on until 6 and a 6. This is the values you can get, so all 6 of them. All right, but I also made a table here where I indicate the dice 1, dice 2, and the combinations that you're going to get. So we're looking for the combination out of 36 because this is a 36 grid here, or 6 by 6 grid gives you 36 squares. All right, and if you look at the combinations where you have identical numbers or the same number, it's going to be this ones that I've indicated here. And out of these 36, 6 of them, which then simplifies to 1 over 6. That is the probability for you to roll a double, the same number. Question 4, when 2 ordinary die are rolled, what is the probability? This is the one that I was saying, all right? Did you find a prime number appear on both dice? Of course. So prime number on both. So if I bring them in, so remember, they're saying, not at least, they're saying a prime number should appear on both. So we expect something like 2 and a 2, or 2 and a 3, or 2 and a 5, or 3 and a 2, 3 and a 3, 3 and a 5, and so on. So this is 9, all right, if you count them out of a possible 36. Now 9 out of 36 will give you 1/4, and the probability that the prime number appear on both dice is 1/4. The B part says again, at least one prime number appears. So here, we have got the condition that, like what we had before, all those 9 out of 36. But now we also have to bring in all the other combinations where there is at least one prime number. Like 2 is a prime number, 1 is not. 3 is a prime number, 1 is not. So it's all those red ones plus these other ones here. All right. And if you count them up, you are going to get 3 quarters, or 27 over 36. And you simplify 27 over 36, you get 3 quarters. They say only one prime number appears, so it means it's all the ones that you see in red here, because if you have the combination of the ones in red, it's only one prime number appears, like 3 and 1, where 3 is the only prime number. Okay, so if you count them, you realize you get 18. If you count these red ones that I have here, out of 36 possible outcome, and that simplifies to 1/2.